So the types of traditional earthen architecture buildings and the localization around the world. One example, the first one I want to show you is this one. It's called Alterbau, which doesn't mean anything else than old building in Germany. It's in Geislingen an der Steige, Germany, from 1445, so quite old. It is an 8 stories building of a timber frame construction. This is a very typical way of building from the Middle Age. You know this from other countries as well. There are a lot in Belgium, for instance. The advantage is obviously that the structural element is the timber beams, and then the infill is with earth or mud. The next example will probably remind you more of what you also know from Oman. This is the Pueblo de Taos in New Mexico, USA, from the 11th to 15th century, even much older. And it is a mud brick dwelling and became UNESCO World Heritage. Another one closer to your place in Yemen, in Shibam, from the 3rd century, very old, the so-called Manhattan of the desert, because you have high-rise buildings here, 500 mud brick residence towers that are up to 11 stories high and 30 meters high. Pretty impressive. I don't know how much they have been suffering now during the Civil War, but this is really an amazing part of the world to see. Also in a very different shape, as you can see, and also almost as old, from the 5th century, is the Tulu in the province of Fujian in China, also a UNESCO World Heritage, and they are building, until now actually, those round-shaped houses, and they are, they are made out of rammed earth. Then they have this patio with balconies, which is providing them a space, a safe space for social lives. Very interesting. Then the next one in Africa, in this case, is the land of the Batamariba, Kutamaku, Togo, also a World Heritage, UNESCO World Heritage project. So here they just have hand-applied wet loam, and they built those round-shaped spaces that look like little castles, and then they make just a little decoration on the outside, just with those scratches. In other areas close to it, like in Burkina Faso, they have then proper paintings that also look very beautiful. But I don't want to stay only with those examples of old heritage. I will proceed here again, an overview of the appearance of earthen architecture in the world. So you can see, apart from the rather northern hemisphere, you can find traditional earthen architecture pretty much all over the world since many centuries already. The next topic is the raw material earth, about the formation, the composition, and the different types of earth. So first, this very simple sketch shows you where it comes from. It's pretty much always coming from the mountains, and by the impact of the weathering, the sun and the rain, etc., it's then washed down into the valleys where it's accumulating. And this is then the area where you can find this raw material, the earth or the mud, as it's mainly called in the Middle East, that you can use then for building materials. This is an example exactly from Oman. You know these pictures, or this a lot, of course. And you can see on the very bottom, this is the material, the raw material that you might have to improve a little bit, but you have this all over in Oman, and this can be used for building. Then the testing for using, so usually you start with a source and you do some little testings with sievings, with some little salt tests, because salt is always creating problems in construction materials, not only in earthen materials. and strength tests, etc., then you might have to wash it, you have to maybe add some additives, whatever, and then you can get it on a bigger scale and create your material. In this case, it's shown to make it with mud bricks. The composition, so you see that there are different compositions of this earth. You have everything that is bigger than 2 millimeters, you mainly call the gravel. Then you have the sand between 0.05 and 2 millimeters. Then the silt, an important element for the earth. It's because it's not only clay. Some people think the earth material is just clay, but it's actually the mix, because they have different properties, and only in the combination they provide you the good properties and the quality that you require then for building with earthen material. And finally, the very fine material with less than 0.002 millimeters is the clay. And also interesting to see, depending where your source comes from and what additional minerals are in there, you have very different colors of soil. So you have the more yellowish and reddish one, which is due to iron oxide, but you also have it more going into the greenish, even very white clay or earth, and almost dark black, everything. And then obviously you can mix it and get all kind of variations of colors, which is also a very nice way of creating architectural features. So now I'm coming to the topic that is very important, the advantages of climatic advantages and the properties of Earth. First of all, I'm showing you here the recyclability versus the destructibility, and we are comparing earthen construction with the more used concrete buildings. So on the top you see what I showed you in 2 or 3 slides before, that you build here with mud bricks your building that is then lasting for a certain time, let's say 30 years or something, and then it's abandoned or it's broken down. And the good thing is, just by weathering, it becomes back just natural soil that you can then, by adding water, reuse again and make new bricks that you use for the next building. If you compare it with concrete, you already start with a lot of energy you have to put into to make cement out of the raw material, and to build up this house then in concrete. It also lasts for a certain time, and then you need big machines to break it down and to crash it down. You need more energy. You have to bring it into a firm that is specialized on this, that uses more energy again, and then you can put it back into the new mix of concrete. But this is also then limited because it's diminishing the quality of concrete. So you see that it's a completely different approach. The mud or the earth is recyclable. You can recycle again and again and again, while you have then limited possibilities for concrete. Not less important is the natural cooling about Earth. And this is something really very nice, especially in areas like in Oman or the neighboring countries. What you see there on the top is a building in earth or mud. You see that during daytime, you have the sun that is heating up the building, but the mud, it has this nice feature that it gives away, while heating, it gives away humidity into the room, and by this it's cooling the room. And then if you have a cross ventilation, which is important during nighttime, then this material takes again the humidity that can give away again during daytime on the next time. You see then on the right side the diagram, which shows the difference between the hatched line, which is the outside temperature, and the brown line, which is the inside temperature. Compared to the same kind of building in concrete, it's heating up, and once the concrete is heated, then it gives away the heat into the room, and you have a very high and hot climate, not only outside, but also inside of the building. And then when you cool it down during nighttime, you can, of course, cool it with cross ventilation as well, but then it's even cooling further down than the other building, and the next day it's heating up again. So you have a natural climate advantage. That was also, by the way, we are not the first one to study this, obviously. Some of you guys might know Hassan Fatih from Egypt, who did a lot of studies about this in Egypt a few decades ago. This is then some measurements that we took in one of our projects close to the border to Oman, in Al Ain, UAE, the Majlis in the Mueji fort. This was one of the first buildings I was involved in. So we did this, measure the temperatures, similar like you've seen before. And you see that this was measurements that we did in summertime with reaching temperatures of 45 degrees. And also we measured the humidity. So you can see that it's going into the other direction because the mud is taking up the humidity. And the brown line shows you that obviously it's still warm in the building, but completely different to 45 degrees. We are reaching temperatures of 37, but far off 45 without any additional cooling system. And this is already providing you a much more comfortable environment. The reason is shown in this slide. So what we are showing here are again on the top the earth plaster, on the bottom the cement plaster. On the left side you don't see much of a difference. This is just a section through the plaster. But if you take the green area, then this is what is shown in the next picture. You're going more into detail, more microscopic view. You already see for some reason that more water molecules are gathering in the earth plaster. And why is this? If you go even further into detail, you will see that on the bottom, the cement cannot take more than the actual pores of the cement, while the earth plaster, it has, and this is due to the clay and the silt that I showed you further before, it has a lot of little plates. And those little plates, first of all, when they get wet, this is why you feel that it's getting very muddy, the material, and very sticky as well. But this also leads to the effect that between all those little plates, water molecules can be taken by the mud and taken and given away again then when the temperature rises. And this is why you have then on your right side the big difference of temperatures or absorption of water, sorry. Then the strengthening of local resources. I think this is also a very important topic. First of all, by using this material, you're preserving natural resources and energy, as I showed you before. Then you have this long-term sustainability, also because you can reuse and reuse it. And if you're following some principled details, you also have a rather low maintenance cost. The next is, it's the reappropriation of local building traditions and identity. So in a country like Oman, where you have a lot of tradition and also heritage buildings, this is obviously giving the society also some trust and some good feeling about using this material where they already know how it's done. And finally, you can also strengthen the local economy with it. And I think Wayne Switzer will talk about this later on again. The building techniques. There are obviously a few more than those that I will show, but these are like 3 of the main techniques. There are others that are kind of mixes of those, but I only want to show you quickly those 3. So the first one is the sun-dried bricks that are used for masonry. That is later on plastered. You see picture 1, you have the raw material, the mud that you're mixing usually with straw, which is giving you, which are fibers like a reinforcement to prevent cracks during the drying process mainly. You're putting this into the form in picture 2, then you just let it dry by the sun. If it's very hot, you only have to make sure that it's not drying out too quickly, otherwise it will shrink too quickly and create cracks again. And then you have your ready sun-dried bricks that you use for masonry, like in picture 4. What is shown here already, that you are putting it on top of a foundation that is not water sensitive. This is one of the important details, that you don't have constructional problems. And then you build it up like in picture 5 and plaster on top of it. And this is what it looks like in reality. This was one of our projects that we had in Pakistan for a little hospital for post-war clients or patients. The next is the so-called rammed earth construction. You saw the projects, the heritage projects in China. They were using this technique. So you also have your raw material on picture 1. Other than the other brick material, you don't put any straw because the principle is a bit different. You're using a shuttering, very similar to the shuttering that you also have for concrete constructions, but there you put your material inside and then you use mechanical rammers and compact the earth and give it a certain strength. And by this, you go up higher and higher and build very strong and massive walls. This is what it looks like, a project that we had as well. So again, these are the single steps that they are doing with the shuttering and then ramming. There are obviously rammers that you can use, very simple ones that you can just build your own on the construction side. There are other professional earth material artisans, I would say, who are using more advanced mechanical rammers, but this depends on the project and the speed you want to proceed. The third one is the COP construction. This is something that is used in different countries as well. We used this in one project in Bangladesh, but it's also very known in Germany. Now it's only used, at least in Germany, for projects of heritage repairs, because this needs a lot of manpower. So you have the material that you mix with a lot of straw in this case and longer straw elements, and then you soak it and prepare it and build up heaps of those materials along the wall where you want to have it. And then, like shown in picture 5, you cut it off on the edges to create, after drying off, to create just a straight wall. And once this is done, then you put the next layer on top of it. And this is what it looks like. So this was from our project in Bangladesh. You see, it's also put on a small foundation that takes the whole building out of the wet area. And then you put up this material and cut it down and have a very straight and a pretty strong wall. The big advantage of this is you're using rather thick walls, and it's insulating as well, but it's also strong with a long fibers. So if you want to create later, after you finished your buildings, openings, you can, if they are not too big obviously, but you can easily cut it out and you don't need any additional strengthening elements like lintels or something. That's really nice. So now I'm talking about the heritage conservation, and I will only show you a few elements. I've been working personally on many others already, and obviously you have so many all over the world. I'm starting with the Al-Jahali fort in Al Ain, so very close to the Omani border. And this was also our first project, like I think 12 years ago in the Middle East. So you had this traditional fort, which is completely made out of earth or mud, and then you used for the, similar to what you know in Oman, you use timber for the roofs. In this case, it was palm trunks. And what we did, there were pretty bad damages, so we had to repair this, and we dismantled all the really broken parts or damaged parts, which you can see on the top left part. But then we put it into the courtyard, so the top middle picture is showing you this, and soaked it again and reused the same material to build bricks again that we used to repair the old building, so with the original material. There is nothing better for sustainability and also for heritage repair measures, because this is the best way of treating a heritage building by using the same material again. And then replastering, if the material was not enough, then we brought maybe local material additional, but just by using the same material, we created this beautiful space. We added then, which you will see, some new elements. I showed you before that we measured in the neighbor project Majlis of Al-Muaji the temperatures. So obviously above 30 degrees, not a temperature that you want to have in an exhibition space, or even not in a living space, of course. So what we did, we added a cooling system that is integrated into the wall, into the plaster of the wall. So you see here on your left side, those pipes that are running on the wall, and there we put cool water through, and there we plaster on top of it. And the plaster of earth has the advantage again that it can handle very well the exchange of humidity. And with this, even if the wall gets cooler, you don't create automatically problems of condensation if the system is running well. We have then a very nice climate effect, because you have then the coolness coming from the wall and not a very noisy and blowing effect that you have from the ordinary cooling system. And you see on the top right what it looked like then at the end, or what it looks like at the moment. After we finished, we have obviously new window elements that are also necessary to isolate the inner room for the exhibition, and the rest is all in traditional earth and mud. We added some new, more modern appearance for some of the exhibition spaces with a more fine earthen plaster. And this is what it looked like at the end, the completed restoration. So from the outside, it just looks like it always looked just repaired and neat. On the inside, we have then some of the spaces that we opened to use it, like you can see on the left, for a majlis, then on the middle and on the right for the exhibition space, to create a mix of tradition and modern space. Then I want to show you a few pictures of Al-Jihad in Oman that you certainly all know. First of all, those surrounding buildings of heavily decayed earthen elements. And I will show you why I want to talk about this as well, because I think this is a very valuable heritage that is in so bad condition that you have to be very careful if you don't want to destroy it completely. And you see with those very big cracks walls almost falling apart or already washed into the ground. This is sad to see, but it's not too late to do something about it. And even if you look at the bigger buildings, we don't know what this means now, but you can see a lot of visible cracks in the bearing structure. So at the end, this is something that if it's not done yet, we don't know about it now, but this needs a proper assessment to see whether this is really dangerous to the building, and then you have to take the right measures. And this is exactly one of our strengths in our company. We have one of the most renowned experts in our company, Professor Christoph Ziegert, who is doing exactly this, and for this reason also working together with ICOMOS and UNESCO. And here you see then an example from Al Ain, the Abdullah bin Salem Al Darmaki house in the Qattara oasis. And you see that it was a very similar problem of the buildings 2 slides ago. The cracking analysis had to be done, but it was really about to fail and to fall apart. And so the first step was to do some emergency conservation with scaffolding and supporting elements, bracings, and then building the cracks, stitching it together. In this case, it was possible to do it first with some masonry that we used, but not only. And at the end, you needed some kind of clamps. And this is how the repaired building looks like now. And now it's safe and will stay like this for many years or decades without having to fear that it's falling apart and destroying the heritage. And also it was obviously a big danger for people passing by. Now I want to quickly show you some elements of modern architecture, not much, but some elements that we did ourselves in Germany. So first you have this, we call it the new life for peat shed. So what we did here in Tschechien, Germany, there was this shed or structure, timber structure, that the client, a friend of ours, bought, and he wanted to reuse it because it was meant to be destroyed, dismantled for building some new houses. But he wanted to have it, he dismantled it and built it up again. But it was only used for storage reasons before, and he wanted to have a workshop and a living space. So what we designed then is to put a house inside of this house, and this is then a modern earthen building inside of the old heritage timber structure. And this looks very beautiful and goes very well along. I will show you some construction principles and some little details. Here you see also those pipes running in the walls. Obviously in Germany, we don't have the problem that it's getting too hot. It's the opposite. It's getting too cold. So this is a heating system, a wall heating system. And then a few details, and you can already see how nice this looks on the bottom right side, where you have the outside of the old timber structure, and then this modern space, the outer wall of the facade of the mud building. And these are then a few pictures of this very modern and beautiful space of earthen architecture, which actually embraces and even gives an accent to the heritage of the timber. Beautiful, and of course, from a climate point of view, also really very nice. I've been there a couple of times. It's really a very nice living space. Then another one where we also combined a heritage with a new element. So it's in more or less an extension of a heritage building. You see this is a stone construction, an old one, and we added a mud building. So this is what it looked like at the beginning on the top buildings, top pictures. And then we added some spaces inside of the existing and some extensions. And what we used here is also a lot of rammed earth. And as you can see, this gives you a very nice texture, looks beautiful, very neat, and gives you a warmth as well but a very modern look, and especially in combination with those other elements and details. You see this with a fireplace, with this modern staircase, the sink, and this sitting area, which also almost looks like a medulis. Very modern, very beautiful, a timber roof, and again, a good example of modern architecture. Quickly only about our company, ZRS Architects and Engineers. I told you that the main office is based in Germany, in Berlin. So we have different skills that we provide to the client. There is the conservation with the assessments of existing buildings, structural design, because we are engineers and architects, building physics, energies consulting, building planning, also fire protection and certification, and then obviously all the sustainable part with earthen building, material testing, and research and development, including our own in-house laboratory. Here a few countries that we've been working around, especially the Middle East, although I already realized Pakistan is missing, I think. So apart from UAE, where I already showed you some examples, there was Doha, Iraq, Jordan, Lebanon, Armenia, Azerbaijan, Afghanistan, also Nepal. Pakistan is still missing on this overview. And obviously I've been many times in Oman, and we looked at many interesting projects, but so far we have never been working there. So maybe this, and hopefully this can change as well. Our structure is ZRS Architects and Engineers, just to give you a short idea. So there are the engineers, there are the architects, and there's ZRS Limited, which is our dependence in UAE, in the Middle East, and all this is added by the administration. And this is also what I showed you. This is very important, that we are really doing also scientific research and testing in our own laboratory, which is specialized also on earthen materials with strength tests, adhesion tests, salt tests, etc. And now just two short sentences about the post-oil city, because this is also very important for now and the future, not only of the society, but of the world. And this is then going to lead to the next speech, to the talk from Wayne Switzer, who will talk a little bit more about this. So we know that since decades, we have a problem with climate change. We are using too much resources, and we are using too much energy. And what is the building sector? What is the part of the contribution of the building sector, and what can we do about it? Obviously, we started to live in very simple huts and small houses, then still quite sustainable houses, as you could see at the beginning of those timber structures, for instance. And the more modern and advanced it became, the more we used resources, oil and energy. And we are reaching now the peak of this, and we have to see what we do, because oil will not be available forever. And at the same time, we know that this is creating a problem with the climate change. And we think by using those natural materials, we can be part of a positive change. So climate change and resources scarcity are realities that require us all to radically rethink the way we live, build, and consume. And natural building materials are locally available and allow us to design energy efficient, low carbon buildings for a post-oil society. So this is the last bit I wanted to say. Thank you very much for your attention. I hope it was not too long and not too much into detail. Certainly, there are many things to talk about. With this little last piece of picture of our project in Pakistan, I want to finish my little talk. Thank you, and I will give over to Wayne, who will continue then the talk. Thank you very much.
Okay, thank you, Sylvain, for that very comprehensive presentation. If you will close your screen, I will share mine, and then we will begin. Yes, okay. Here we go. So, Assalamu alaikum. Thank you for having us. It's a pleasure, actually an honor, even to be speaking at the Majlis Al-Khanji about such a relevant topic. And I think now that we have a very comprehensive understanding of earthen architecture, especially historically, I'd like to use the second half of this presentation to focus on the relevance and the potential for earthen building in Oman, and why this can be actually a very important material for the future construction of this country, not just historically. That might seem a bit naive given the difficult economic outlook that we have in front of us. However, I see it really as a source of optimism and an opportunity. So in doing so, I would also like to highlight some of the efforts that we've already begun at the German University of Technology, where I'm teaching. And basically, hopefully this will help to illustrate how this can be relevant here. When we think about materials of the future, probably most of us, we don't think about earth. Maybe we think of mud construction as linked to the past, or things that we know from villages or perhaps historical houses, heritage. But more and more, and this was already touched upon in the last presentation, earth is really being regarded as a material with great potentials for development. For example, in the year 2012, so already 8 years ago, this magazine, Smithsonian, which is a well-regarded scientific publication, published a list known as the 40 things you need to know about the next 40 years. Obviously, issues such as climate change, urban farming, these were all included. But interestingly, number one on that list was this prediction: sophisticated buildings will be made of mud. And I think that's very interesting. And even though mud is a very significant part of Oman's history, for this presentation, I would really like to focus on how sophisticated this actually can also be. The truth is, we've been building sophisticated earthen buildings for centuries. These are examples that you might have just seen from the previous presentation. Both are sophisticated buildings. Both of them are made of mud. On the left, we have Shibam. Here we have high-rise buildings made of mud brick, over 30 meters tall. And on the right, we have a project which was proposed for the multi-story housing project in Paris. Here we have about 400 years between the projects. And for me, the question is not really if we are able to build this way. The question is really why. Why are more buildings going to begin to use these techniques? And why, more specifically, is this type of construction relevant for Oman? There are three primary reasons, let's say, and these have been touched on, so I will try to go quickly. The first is that earth construction, building with mud, tain, this is already part of the architectural heritage in Oman. For thousands of years, this material has been the definition of the color, the texture, and the feeling of this country. Building with earth offers us this opportunity to reconnect with this heritage, something which is uniquely Omani, not an imported technique. We could even say that earth is really in the DNA of the culture already. The second is interior comfort. I don't need to go into the scientific details of it, since we had that in the last presentation, but I think everybody on this call knows the feeling on a very hot day, this feeling of relief when you go into a building made with very thick earthen walls, and the coolness and the refreshing air that is being breathed through these walls. Perhaps you've experienced this in some villages or in houses of the past. These are walls that breathe, and they purify the air by absorbing humidity, and this is scientifically proven. This is something extremely important in our climate here. And finally, the issue of renewability. So like no other material, earth is a material which can be recycled indefinitely. That means without a loss in quality. So were I to take this building here, which has very eroded bricks, if we were to take these bricks, crush them, remix them with water, and create the same bricks, we would have the same bricks at the exact same quality as the original ones. So this is for us really truly recycling, not downcycling where we have to invest additional energy to produce a product of lesser quality. Now the material, which has largely replaced earth, especially in Oman, is concrete. We're all familiar with the advantages of concrete. We know that it has superior compressive strength, it has extreme durability, especially tensile durability, and so on. However, in fact, when we look more closely to issues of sustainability, what is really going to last and help Oman thrive and sustain itself, we find that concrete is actually lacking in many areas. For example, its lifespan, its recyclability, but most importantly, this last point, the embodied energy, meaning how much energy do we have to invest in order to get a quantity of this material. And most notably, this embodied energy is huge in comparison to earth, when we compare concrete with earth. And this is becoming a very, very relevant topic because as we know, energy is becoming more and more expensive, and it's going to become more and more expensive. And this makes the current way of building very, very unsustainable. At the global scale, the comparison looks a little bit like this. If we were to graphically compare the embodied energy of 1 cubic meter of earth and the embodied energy of 1 cubic meter of concrete, the difference is, well, it's indisputable. And this makes a big difference globally because after water, cement is actually the second most sought after resource in the world. That means more than oil and more than gas. And cement production alone accounts for approximately 5% of all the greenhouse gases worldwide. So this is a massive impact at the global scale. How about at the local scale? Well, here in Oman, we can also see that reducing cement can make a huge difference for us as a country. For example, if we were to just take residential construction in Oman, and if we were to just take 50% of the material that's used in residential construction, the cement-based material, and change that to earth-based material, we would have huge potential savings every year, not only in the amount of cement that we would save, but the amount of carbon dioxide that we would produce, and most importantly, the amount of energy that we would save. But sustainability in Oman is not really just about saving energy. If it was, we could just make the argument, why not just produce more energy instead of changing the way we build? What we actually have to realize is that there is a huge potential in earthen construction to improve the sustainability of our building culture here. If we understand the way we build now, most of our processes are on the right side. We are in this column of industry dependency. Our materials, our labor, and our construction, we are extremely dependent at the moment on imported, on fossil fuel-based, non-renewable resources, low skill, low wage labor, and on-site construction. What we would like to do, obviously, is move to the left side, where we localize our materials, our labor, and our construction moves off-site. And this will make ourselves much more sustainable in the future. It is really about shifting from dependencies to self-sustainability. This is where earthen construction becomes very interesting because it offers us the opportunity to reduce dependencies in two key areas. The first is in non-renewable materials, such as cement or concrete. And the second is on low-skill, low-wage workers. The first, when we talk about material, it's quite obvious. Raw earth is extremely abundant. We will never run out of earth, never, because it's always renewing itself. And in fact, ironically, we are producing more usable earth now more than ever in the form of excavation. Usually we are paying to transport this excavation away. Now the idea of reusing excavated soil for construction purposes is not a new one. This is, especially in urban centers, it's becoming a very, very hot topic. And it's a central theme in what we call the circular building movement. So circular building is a term where we examine the entire life cycle of material. So from the time that we extract it out of the ground, we use it, and then ultimately the waste that's produced. And circular building tries to eliminate the waste by closing this loop. So we ensure the materials maintain their value and they're reused indefinitely, basically in a circular way. So in the city of Paris, for example, they are planning a new subway system where they're going to produce millions of tons of excavation. Now, instead of paying to transport that earth and that excavated soil out of the city, an organization known as Terre de Paris has decided to keep that earth inside the city at a centralized depot, and they're going to now produce building products from that excavated soil. Similarly, in the city of Brussels, they're doing something very almost the same. They build an architecture and building firm known as BC Materials, recognize that each year approximately 22.5 million tons of excavation is produced in Brussels and Flanders alone. Now 75% of that excavation is completely unpolluted. It's not contaminated, it can be used. However, 100% of that excavation is ending up in quarries or in non-circular areas such as for road construction, so it cannot be reclaimed. So what they did is they simply created a network where this excavated soil could be brought to them, they would process it, and then they would produce these products, which are blocks, bricks, and plaster. And then these can be sold within the city. The earth never leaves the city. Now, the second dependency that we were speaking about was low-skill, low-wage labor. And in fact, when we talk about earthen construction, and for example, many of the images that we saw in the last presentation, many of us might be thinking, well, that is what earth construction is, right? Low skill, low wage. And for most of history, that's been true. The technique is not complicated, it's very labor intensive, and that's one of the reasons why it endured. But this is also one of the reasons why it has not endured. In contemporary construction, earthen construction is far too inefficient, right? We cannot afford this amount of time and logistical difficulties when we're building today. We are not advocating a return to the techniques of the past. This will really not improve our dependency on low-skill labor. What is needed is an upgrade. Earth is in need of an upgrade. We need to transition from low-skill, low-labor, labor-intensive work to high-skill, high-technological processes. We basically want to industrialize Earth. This image shows basically the same product, top and bottom. The only difference is that there's a different production technique involved. Basically, we need to industrialize just as other industries did 100 years ago. What this industrialization offers us is the opportunity to work in a controlled environment, something extremely important here in Amman as the climate is brutally hot. This also allows us to produce much more precise and efficient products. And most importantly, one could argue that these conditions and these fabrication methods also have the potential to reintroduce Armanis into the production process. Because what they would be doing is they would be entering this production process not as workers, rather as building technicians. They would be supervising and overseeing high efficiency tools to be applied to this material. These tools then can be applied to produce products of very, very standard quality, also in modules. This is, for example, a Spanish firm known as Fertitera, and they are using soil, local soil, to produce blocks, which are extremely sharp and precise, neat and clean, can be used in many different applications. And along with that, what they also have is the ability to test these and produce spec sheets. And so that now we have norms and standards and guarantees for these products, as we do with any other contemporary building product. So in order to meet these contemporary standards, many countries have already begun starting to make these fabrication facilities. Countries such as France, Switzerland, Germany, the United States, they are investing heavily in trying to develop these fabrication techniques. One of the better known large-scale examples is this one. This is the Reprolabels Center located in Switzerland. And this is a building facade which is over 11 meters high and over 100 meters long, made entirely from local earth and gravel. The technique which was used here is known as rammed earth. So we have layers of earth which is poured into a formwork and then compacted. Formwork which is very similar to those used in concrete production. Then this very large wall of compacted earth is cut into large blocks. Each of these blocks weighing about 3.5 tons. And then they're moved into a storage facility. So they're just moved into a hall where they can air dry. So again, no chemicals involved. They simply just need to dry in the air. Each one is labeled and then coordinated for their precise location on the building. I was personally involved in this project, in producing these blocks. And I remember the feeling of seeing these blocks stacking up in the hall. At some point we had over 200 blocks. But this storage allowed us then to minimize our time on site. So basically we kept them here until the site was ready, and we minimized the amount of time that we were outside, actually. These blocks were then loaded into a truck. They were transported to the site, and then with a crane they were lifted and then set into place one by one, basically like large bricks. The setting involved was actually into a mortar, which was also made out of the same material. So earthen mortar for earthen blocks. And then the seams between each of these blocks were smoothed out, they were retouched. And the result was that you had a very homogeneous, smooth surface at the end. This was the exterior. If we move into the interior, we see that it's a factory for herbs. And so they wanted a different, smoother and more, let's say, refined finish on the inside. So this was finished with an earthen plaster made from, of course, the exact same material, simply sieved and much, much finer. The result was that in 6 months, we were able to not only produce these blocks, but to store them and to set them into place very efficiently with minimal time on site. So this became a very high quality building facade made actually of the most basic material, completely local soil, which is 100% recyclable. Now, this sort of technique is not limited just to Europe. For example, here we have an example from Morocco, where a building firm known as Argilex is also taking this technique of prefabricating blocks off-site and then lifting them and setting them into place, setting them on an earthen mortar bed, and then finishing them with a plaster to very fine results. So back in Amman, let's say about 3 years ago, we started to ask the question, how can these ideas work here? At the German University of Technology, we were very inspired by these examples. So we decided to do a small test project with the students where we would use the same technique of rammed earth prefabricated in blocks. At our university, we emphasize for the students to get involved in the process from the very beginning. So of course, they were involved in the mixing to familiarize themselves with the basic material which came directly from the site of our campus. From there, they did different testing of compaction, adding different materials to see how they would be adhering to each other, the binding qualities of earth. And then they produced the blocks themselves. They rammed these blocks in formworks, and then we set them outside to dry, which of course in Amman takes no time at all. These blocks were then transported up to a site using a forklift, so very rudimentary. We had to use the tools that were available to us. And again, the students then led this project, stacking these blocks into place, one by one with earth and mortar, to result in a small tower. Now, it's nothing like a huge building, but what it showed for us is that yes, the soil and the processes that are available in other places can absolutely be used here. And that tower is, of course, still at the Geotech today. So in the coming semesters, what we decided is we needed a studio to study this properly. And we decided to name this the Circular Oman Studio, going back to this idea of circular building that I mentioned earlier. And the first question we asked is, what would such an industry in Oman look like? What would we need in order to promote or develop earthen construction here? And so we realized that before buildings, we need building blocks. We need the products, actually, to build. So the first task for the students was actually to design a production facility and a showroom and a testing lab for such products. So essentially the students were tasked with designing a factory which would be on the site of the Geotech campus. They did this, of course, under the guidance of professionals, also guest experts who visited our studio here in Alban. And what was interesting was to see how the students not only made earthen buildings, but earthen buildings which went in combination with concrete structures. So they used blocks in different ways as shading techniques, maybe as musharabiyya, also as walls which could allow a certain amount of light in. And then in the second semester, we moved our project, we upscaled to see how can we make a hybrid building where we have earthen infill or an envelope of earth in combination with a concrete, reinforced concrete skeleton structure, because this is really where we see the most potential, is that we make use of the concrete structures which are available or that are being used, that are, let's say, trusted by engineers, and that we integrate earth as infill and to use it in a way that it's doing what it does best, let's say. So the students were then given a site here, actually an existing concrete structure, which is located in Al-Jihad. They were taking this concrete structure and then making proposals of how this could be infilled or wrapped with earthen material. And it was very interesting to see how many different varieties of solutions that the students came up with. Everything from wrapping the building to infilling it, to creating space between the blocks, and proposing various spaces for different programs and uses. Again, I think it's important to emphasize that we, as a studio and in general, we are not trying to make an enemy of concrete. We understand the possibilities and the necessity for that material. What we are proposing, however, is to use earth for the properties that it can also offer. So the idea of a reinforced concrete structure with infill earth or an earthen envelope around it is for us extremely attractive because it really represents, let's say, the best of both worlds. These academic studies basically showed us that innovation is the key. We really have to innovate in a way. And we believe that innovation in earthen construction occurs best under these situations. We want to apply high-tech, high-specialization tools to a low-tech, low-energy material. What we realize, though, is that what is missing is a platform in order to bring the different stakeholders in Amman together, to recognize how they can engage with each other and identify what their separate values are. So in 2019, last year, we established what we call the Earthen Building Initiative, the EBI. And this was intended to be such a platform. So whether it's the government wanting to shift their economy towards more renewable energy and offering incentives in the forms of subsidies or tax rebates, or whether it's the industry who wants to use less energy intensive techniques and create jobs for Omanis, we are here for that. That is our purpose as the EBI. We've established a website. Some of you might already be aware of it, with an Instagram page where we keep people informed about what we are doing, including events such as this one that's going on today. And the very first event that we had earlier this year was a symposium in February, where we invited experts from abroad. Sylvain was also part of that symposium, to come to Amman, to Geotech, and to present their knowledge and what they are doing as practitioners of earthen building, and to share with us what they felt the potentials were in this country. We had a 2-day symposium. It was a lot of fun. And most importantly, we were able to have a lot of critical discussion among the people. The first day was actually a day of presentation and discussion among the experts. Some of our guests included specialists in German norms and regulations. So how do we actually bring this into standard construction? And some of them were actually practitioners who have their own business. And most interestingly, we had also the Spanish firm, Spettetera, who are working with cement producers to reuse their existing machinery, so the presses that they use for cement products, to reuse them to create earthen products. The second day of the symposium was a practical demonstration. So this is where actually all the people who attended were able to participate. So less talking and more doing. And this allowed participants to touch, to feel, to ask questions, to experience what it's like to have, for example, earthen plasters in the home, or What is it like to have an industrialized earthen block, and how can we use mechanization and efficient means to set these blocks in place? How can we get away from this stigma, this old image of earth being this handmade, low-tech, low-efficiency practice, and move it into the 21st century? What we also did during the symposium was something important. We had a survey where we asked 3 simple questions. And the questions first was, what field are you working in? So we wanted to have an idea of where people were coming from. Interestingly, most of them came from the field of academia, which was a lesson for us. So that revealed that the first challenge of earthen building is to convince the industry and the government that this is actually a relevant topic, because most of them obviously didn't feel it interesting enough to attend. The second question was basically revealed to us that the greatest challenge that people see for contemporary earthen construction in Amman is not actually due to the cost or the appearance of it. It's really a lack of knowledge. Techniques were simply unknown or not being taught. This was the opinion of the people attending the symposium. And the third question was basically asking, what do you think would be the most effective incentive to encourage earthen building in Oman? And then again, here we were surprised. They chose that product approvals, basically to create regulations and standards for earthen products, would be the best way to move earthen construction forward. And this would be actually interesting to hear the opinions of this audience today. I would also be curious to hear what you all have in terms of your opinions from this. So for the EDI, this was actually a very important survey to hear from. And that's why, for us, the very first priority is to cooperate with ministries and municipalities on the process of this regularization, or this regulation and standardization of earthen building products for the market. That's the very first thing we like to do. The second is we want to educate and demonstrate to engineers and architects about the potentials and the beauty of these products, because in effect, as we saw in the last presentation, we do believe that these products are beautiful and durable and healthy. And earthen plasters, such as the ones that you see here, can add an enormous feeling of depth that is really meaningful to a space. And finally, we are really actively seeking industry partners who are forward-thinking enough to recognize the potential for this new market. And especially for people, for example, who are in the cement industry, who are interested in how they can use their existing infrastructure towards this new market. How can they retrofit the machines that they already have and avoid this initial capital investment and produce a much more sustainable building product? Our goal is really to coordinate the efforts of these stakeholders towards the innovation of Earth. That is really what the EBI is focused on doing. And in the process, we want to create healthy, high-quality buildings which are rooted in the natural material of Amman. And I hope sincerely that some of you will join us in this exciting effort. So with that, thank you very much for your attention. Shukran jazilan. And I turn it back to our moderator for questions.
Thank you very much. Thank you very much, Wayne and Sylvain, for this comprehensive presentation. It was very interesting, and we have some questions and some comments as well. I will start to take them. Please, if you have any question, yes, put it in the chat or whatever is convenient for you. So we'll start to take some questions from the chat. I will start with Mrs. Iman. So I think Sylvain, you have answered her already. Could you please bring the comment again into the picture so you explain to the others as well about her opinion? Mrs. Iman, are you with us?
Hello.
Hi.
I heard my name, but I didn't hear your
Yes,
sentence.
we have seen. Yeah, we have seen your comment from the experience in Morocco. Could you please bring that into the picture so everybody can listen to it?
Yeah, sure. By the way, thank you for the organization of this webinar, and for both Mr. Sylvain, Mr. Wayne Switzer for the interesting lectures. About my question, actually in Morocco, we have this, we're thinking about building earth, and many architects and many engineers are discussing that with the communes and the Moroccan and administrative institutions. But each time there is this seismic safety condition that we need to guarantee in each building that came in the discussions. And so we're either obliged to have a structure made of concrete or made of wood, and then we can add earth blocks or rammed earth in the wall. So the structure cannot be made of earth. But in the photos that Mr. Sylvain showed earlier, I saw that the examples were somehow made exclusively of earth. So I was wondering if there weren't applicable laws that hampered the possibility to build exclusively of earth in these specific countries like in Pakistan and Iraq, or if they have another solution that I mean that guaranteed the facts of even while building with exclusively with earth, they were sure these seismic safety conditions needed, and also the national norms. I have a blank.
Thank you, Iman. Sylvain, have you got I think she already typed the question, so if you can just bring it into the picture, please.
Yes, so I would just give you a short idea. Obviously, the seismic problem is a problem that you have almost all over. Do you hear me? Yeah, almost all over the world. And it's very important. In heritage buildings, it's obviously something that was not that much reflected. Some traditional buildings even have this, but most of them don't have it. And once we do conservation of heritage buildings, this is always something that we also have to reflect and do calculations. And we have in our company even an expert that is doing seismic analysis and simulation even for heritage buildings and even for mud buildings. So depending on the project, there are different ways of treating this. If you're talking about a heritage project, it's more challenging actually because you cannot change the construction itself. Sometimes we are adding some anchors or some clamps. Sometimes we put like a constructive or structural mesh around the building that is integrated in the plaster, but this needs to be calculated actually, and it really is a very individual case. If you're talking about modern buildings, it's actually easier because you can from the beginning implement elements that are taking the loads that appear during earthquakes. So obviously this depends then on the region in the world, how often, how frequently, and how strong are the earthquakes. And there are There are information all over the world about seismic activities that you can look at, and our engineers take this then as a base for their calculations. In principle, you can easily use earthen construction as much as others. Just to tell you, a concrete building by itself is not seismic strong. It is because the concrete building also has something like a ring beam or several ring beams integrated. And this is something that you can also do as well as in a concrete building into mud buildings. Sometimes, depending on the strength or the location, you might have to put kind of anchors into the earthen construction, which are then connected to the ring beam. And the ring beam itself doesn't have to be in concrete either. We do it, we can do it in concrete, but we also did it in timber. We also did it in bamboo, for instance. It depends on the country where you are. And actually, timber and bamboo even has, in some aspects, advantages because it is more flexible. And you know that the most rigid elements in earthquake are always giving you the most problems. So very often when you have a rather soft construction, and I would say that earthen building or mud buildings are such, and you have then a very rigid element like a concrete floor or a ring beam, that exactly the connection between both elements is then where it fails and where the building collapses. And this is not only related to earthen buildings. What I obviously agree that this is something that is in most countries, and maybe Wayne wants to tell you about this, not reflected in the regulations, in the local regulations. We do have more in Germany already, and Professor Dr. Christoph Ziegert, one of our founders, he actually was deeply involved into the process of having standards for earthen buildings, and it's even extended now under process. So we have, as one of the first countries, a few standards at least that allows us to make the process easier. Still, we also have in Germany the principle that you have the approval on single approval, so to say, that it's checked by engineers from the authorities by single case when you're not meeting the standards that are available. And then they check the calculations and everything, and then you can still get the approval. This is something where in many countries you have still to work with the authorities, convince the authorities, and I think this can only be achieved if you have expert doing this with some experience, and but it's not impossible, obviously. We are doing this already in a few countries, in many countries, as you have seen, and our standards are always on the safe side because we want to make sure that our buildings won't create any problems. We have, for this reasons, the best specialists on board. So I hope this is in a short way explaining this topic.
Yeah, definitely. I'd like to ask you if it takes a lot of time to do the calculations for each single building, because as you said, there aren't available standards for earthen buildings, as it is the case, for example, for concrete buildings. So if we want to do the calculation for each one, that would...
Well, it depends how much of standard materials you can use. So in Germany, for instance, we have now standards for earthen materials. If you are using those materials that are already certified, then it's easier. If you have to prove that the material that you're just taking out from the earth has the strength, then you need to make laboratory tests. But the calculations, in principle, it's as I said, for modern buildings, it's not that complicated. It's more complicated for heritage buildings where you have to assess first the damages, where you have to see where we can implement new structural elements. While in the new buildings, you know that you can directly put timber elements or ring beams or whatever from the beginning, and then you only have to calculate with the other properties of the used materials. It's not that much more complicated either. It's just that people are not that much used to it, to those different properties.
Okay, thank you.
Ammi Pankaj, if you can unmute yourself and give us your question and your comments, please.
Thank you, Wayne. Thank you, Sylvain. Extremely inciting presentations. Thank you. My question is very simple. Can earthen material be used as an infill on sandwich panel external walls for both thermal and sound insulation? One. Number two, can we use the earthen material to manufacture plasterboards, as we use plasterboards more and more in manufacturing walls, external and internal? Thank you.
Sylvain, do you want to answer this?
Yeah.
It's something I think both of us have the same answer.
Would you rather take more comments and then answer them all together?
No, it's fine. We can address
one
this
by one, because that will take a little long if we do that, and we have a time limit until 1 o'clock.
Can I also ask a question now, or should I wait for some time?
We've got like a list of people, but if you want to go ahead.
I think the short answer, if I'm not contradicting Sylvain, is yes and yes. Earth can be used in external uses as well. If it's a sandwich panel, of course, you'll have to be aware of what that sandwich panel is made of on the exterior. It's been used as infill before. If you're talking about a prefabricated element, of course, there's going to be a bit of design work involved in the manufacturing and the logistics of that. But I'm relatively confident that something like that could be made. And in terms of earth plasterboards, such plasterboards are actually already being made. I believe Claytech, if I'm not mistaken, they do manufacture clay plasterboards, which can replace gypsum plasterboards.
Thank you. That's very insightful. The only reason why I say it about these sandwich panels is because if we're going to adapt the new construction offsite or build offsite kind of model for Oman, for technology and for reducing the amount of unskilled labor in construction, then we need to adapt to certain models which are to do with earth or mud being used for manufacturing panels, external panels, and then how do we infill them so that we can construct the walls in certain dimensions and transport them to remote areas and construction. That's all.
I mean, interestingly, the idea of the panel comes because often one material doesn't do enough. So you need another material on top of it to protect it or so on. The advantage of earth is that often, done properly, earth can fulfill all of those things. So, for example, the projects that I showed, the Reprolabels Center, was exactly that. They realized that they could manufacture a block of a certain thickness and create simply a massive wall, and that would eliminate the need for a sandwich, right? And then they had the structural system on the inside, khalas. Right? So I think these low-tech solutions are sometimes amazing to me because they go against the grain of what we're typically accustomed to in contemporary construction, where we try to find this material and then adhere to that one and then build up these things. When in fact, if we were to just go back to the logic of how these materials behave, and especially with earth, it's often something we're already familiar with, we could make this much more simple.
Thank you, Wayne. Thank you, Sylvain. I really appreciate it. We will probably, if you don't mind, our host, can we also have the contact addresses of our presenters so we can be in direct touch with them at a later point? Appreciate very much. Thank you very much. I must leave for another Zoom call. Thank you.
Mr. Iyad had a few questions. Amit Fadal.
Thank you very much. This was very, very informative. My question is that considering if we can use the earth for the surround and using a hybrid construction with concrete construction and reinforcement, can we look into the use of adding limestone and gypsum to strengthen the quality of the earth if you want to produce blocks? And moreover, if we use it in the new methods of 3D construction to improve the compactability, there been any studies be made if you can use earth instead of cement, plus using limestone, considering local products, limestone, gypsum, and what have you, to develop this new 3D construction? I hope I was clear in my question.
Mm-hmm.
Thank you.
Sylvain, would you like to begin?
Well, obviously, you can combine it with all kind of other materials, like always. I think it's very important how you combine it. It's always a question of where do you put the stronger and where the softer material. And then it's a question of how much do you really want to go to the most sustainable way, or is it because you have something available already that you want to use? We are also combining it sometimes if it's required. From our philosophy, obviously, we always want to go to the most sustainable way. So this is why we prefer to, and this is also why one of our founders, Mr. Eike Roswag, he's now a professor at the Technical University and having the natural material lab there. So we are mainly combining it with other natural materials that are also 100% sustainable. Perfectly is then in our country the combination with timber. As I mentioned shortly before, we did it in others with bamboo, for instance, but we did also combine it with limestone if this was part of the local tradition, for instance, and you can easily do this. I think it always depends on the context. The system of using concrete is obviously not our philosophy, but if you have this as a base already, you can easily infill it also with modern construction then, and at least you have the structure around where you probably have, which makes it maybe easier for you to get the approval by the authorities, but then you still have a big advantage of the rest of the main mass of the building that provides you with the climate effects and still is sustainable. Combining it with gypsum, for instance, we have also in heritage buildings the mix of gypsum with mud. It doesn't really provide you a big advantage, I would say, unless this is really in an existing building. Gypsum can be used, but rather on the inside, I would say, because it's more water sensitive. And you have then, especially in Oman, this Sarouche product, which is also based on gypsum mainly, gypsum and lime. And this is also something that you can combine, but again, and it's very nice to combine actually, especially if you have areas where you need maybe some more protection about water or humidity from the outside or decoration on the inside. But you have to be careful again to follow some basic rules that you don't put, I say in general, there are always exceptions as well, but in general not the stronger materials onto the softer material, because this is then easily decaying. You get then humidity getting into the softer material underneath. And this is, although it seems to be good, in good condition on the outside, creating problems on the main construction. So you have to see on the individual case, but you can always combine it. Just do it correctly, of course.
Thank you, Sylvain. Hussein, would you like to give us a few comments of yours? And then Ammi Simon, please come in after Hussein to give us your comments. Go ahead, Hussein.
Hello, everyone. Hello, Mohammed. Thank you. Thank you, Mohammed, for hosting this and having the effort to make it happen, finally. Thank you, Mr. Khalil, as well, for allowing us to do this in your majlis. Sylvain, Wayne, thank you for this very interesting topic. I have two questions quickly. I'm asking, can the existing cement and concrete blocks plants, can it be modified and redeployed somehow to allow production of these earthen materials, since the infrastructure is available already? So this is my first question. And my second question is, was there any efforts has been presented to, in a consultancy point of view, to be presented to Muscat municipality to allow maybe this shift in regulations to introduce structural methodologies to support this industry? And I think if there is a joint effort can be done, this can be progress really fast. And the reason why I'm saying this is because we have faced some delays on introducing load-bearing systems to have some approvals for some projects that we have in Matra for Al-Khunji Group. So thank you again, and thank you, Mohammed.
Yes, I believe everything you're saying.
If we let Simon to give his comment and question and then answer both together.
I see, okay.
Thank you. Ammi Simon, please go ahead.
Thank you very much. Actually, I was taken a bit by surprise with what was presented. I've been 50 years looking at Burj Khalifa and these tall buildings, Calatrava, you know, all these forms, plastic forms, which are totally out of the world of earthen and earth use. I was building bridges which earth cannot do. But you brought us, one of you brought us down from top of the tower to earth. And I think Sylvain took us horizontally, whilst Wayne is now taking us vertically again. I would like to comment on both, if I may, and ask a question which is very simple. Let me ask it first. Is there anybody from municipality with us? No. And that shows you the challenge we have, because I think everything starts there. Let me comment on your work, Monsieur Rocher. Voilà. And I will not say it in French. You said you wanted to work in Oman, which is I think there's a great opportunity for your work and for your company. However, the block is funding at the moment. Why don't you see what we can do? We can start with something small. If you identify a building, I can do that belongs to an Omani, an old building, let's say in Misfal Abriyin, or in Hamra, or in Manakh for that purpose, and make a deal with the guy. We need a budget. You know, and that should be given to us free. You come and say, look, I can make this out of this without the detail, and it'll cost you that much. If I know how much it costs, and I identify the owner, we can start a private initiative, either on corporate social responsibility grounds, where I can form a group called the group of that house, and proceed with it, raise the money as corporate responsibility, or even, but Pankaj has gone, but I've got here His Excellency Khamis Mubarak. He's a great real estate developer. Maybe we develop that into a bed and breakfast things, as Omanis are doing on their own. So if I had to advise you something, rather than going to municipality and to authorities who do not have neither the will, nor the money, nor the innovation, which is a must, we could do something on private thing. Now, to go to what Mr. Wayne, Professor Wayne has presented, and both your ideas, of course, you concur on energy saving, on future, on recyclability. That's extremely interesting, particularly in a country like Oman. I have used about 4 million tons of clay to seal off ponds on a big project, which is now the biggest street bed in Oman, you know, in the world actually. But we can, so the material is available. But to jump from there to industrialization, it's a bit too early. He's going to face big challenges because you see, Mr. Wayne, he's got a laboratory, he's got passion. Unless the whole society, including first the municipality, to change and accept such construction and put rules and standards and convince, because in your survey, not knowing the product was a main challenge. Then I think we will not advance. See, I can set up a big factory for these in a place where there is straw and there is clay. But to sell to whom at the moment? To get it approved by whom? It can only be done on corporate social responsibility. Help the people in the middle of the desert not to go and buy their blocks in Salalah or Muscat, but take them from what is available in their area, particularly in the Wusta area. Thank you very much.
Thank you, Ammi Simon. Can we have His Excellency Khamis Al-Kiyumi?
My partner.
To please. تفضل عمي.
تسمعني؟ السلام عليكم. First of all, very interesting discussion, very interesting session. However, blocks are widely used in this area.
Mr. Khamis, your voice is breaking.
For example, those are the main blocks. Few factories used in this area. But again, I would say that how to make it possible to reintroduce it to our area. That's all. Thank you. تسمعني؟
لا بس راح كل الحديث وما سمعنا.
سمعنا نصه وما سمعنا الباقي.
الطابوق الطيني أو clay blocks are widely used in Iraq, in Iran, in Turkey, and there are few factories already producing this in both Saudi Arabia and Qatar. So I think what is needed to be done to explore what the question have been raised by one of our colleagues. Can we upgrade the existing cement factory or cement blocks to make it using clay? And I totally agree with you, Mr. Partner, that clay is widely available in Wusta, widely available. Yes, widely available. You know, there is a belt of clay starting from Jamia Sultan Qaboos University, up to Rustaq, best quality. And it has been used, of course, in Bahla, as everybody knows about that. So clay can be one of the solutions, and it has been used in Omani culture as well, long time back. Thank you. Thank you.
Thank you. Can we have Engineer Salim Kimiani, please? عمي تفضل.
Thank you. Anyway, I was not asking to speak, but at the end,
we would like your comment.
Okay. Anyway, it is as everybody knows, you know, this mud material been used long time back, and for example, in Nizwa, there are many old houses in Harat al-Aqar, near Nizwa Fort. If somebody visit that, they call Nizo heritage. It was rehabilitated many buildings or many houses, and now it is used as a guest house. We have
the voice is broken. Engineer Salim. If
we can take this question later. We have a comment from Mrs. Hanan Al-Jabri. She's from Muscat municipality, and she would like to give you her comment.
Oh, great.
Mrs. Hanan.
Assalamu alaikum.
Salam.
Assalamu alaikum. Can you hear me?
Yes.
Yeah, thank you everyone. This is a very great discussion. I'm Hanan Al-Jabri from Muscat municipality. Just to clarify, I know we in Muscat municipality, we are one of the bodies that, or one of the, we are responsible in building requirements, but building materials and the approval of using of any materials in building industry is not one of our responsibilities. It's Ministry of Industrial responsibility. So it's not the municipality's responsibility to give approval for any material to be used or to not to be used in the industry. So I think it is very important that we involve people from Ministry of Industry and to see what are the requirements that they are require to give approval for such a material. And maybe we can take this further because this is a very great opportunity. We have a very big opportunity here in Oman to use earthen material. Thank you.
If I may, could I just speak a little bit? Because
go ahead, Wayne. Yes.
I think it's actually just a nice moment because a lot of the questions so far in this last round have addressed the same topic, the same concerns about which ministry or which municipality is able to push this forward. And there's often a lot of frustration I found in our research that people feel as though they're blocked. They think it's a good idea, but they're not able to move forward. This is exactly the reason why we established the EBI. This is the platform where we identify who those stakeholders are. And in fact, Ms. Hanan, I'm glad that you made that comment. We are actually speaking with the Ministry of Industry about product certifications. And the good thing is that we are not the first people to be doing this. So other countries have already implemented some regulations. Some of those regulations and norms have even come from the company of Mr. Sylvain, partners from them who have helped write those. So in the process, we don't need to invent everything ourselves. We can also adapt what has been used in other countries and been tested, and we can use those same testings here in Amman. We have the products, and then what we need is we need the cooperation of the municipality that we could do a pilot project, for example, something which they could support, they could understand, and then this would serve as an example, for example, how we could implement this. And I think from there, we would have a lot more to talk about because we all know that the thing that speaks the loudest is when something is built, correct? So I support everything that's being said. However, I think that the platform that we've started is actually the very first step to start to get all these different voices to speak together.
Thank you, Wayne. We have another question from Mrs. Shah. Mrs. Shah, would you like to add your question, please? Okay.
I'd like to ask a question if I have a chance.
Yes, please go ahead.
I would like to ask the question to Mr. Simon. Assalamu alaikum, Simon. How are you?
You asked me, how are you? I am good, thank you.
Good. Mr. Simon, you were saying about doing a project on a private basis. Wouldn't we still need to get the permissions from the municipalities to be able to do that to begin with? Even when we want to do a small pilot project on a private basis, we end up having to go through the same loops as any other project we need to do, whether it's a pilot project or others. Because I can think of, when you were saying Manah has this beautiful project of this Al-Balad, whatever it's called.
Decha in Ibra, Manah, so many places. Amra, you're right.
Yes, but the Al-Balad is being restored right now.
Yes, yeah.
And so it would be, I don't know if the engineers or the architects have managed to go to see that location. I think it would be very interesting to get their input on what they would be able to do for that. Because there used to be towers there, 3-story towers that have been cut down, or maybe more, I don't know. But it would be interesting to get their opinions on what would be possible there. And maybe a collaboration with the Ministry of Heritage to do that.
Yes, absolutely.
And then we can get private funding from big corporations from Oman to sponsor these projects, as it will eventually be a tourist project. So that's my 2 cents in that. Thank you.
Let me give you my experience. You see, Ms. Hanan, she spoke about approval of materials. Okay, and it's with the Ministry of Commerce and Industry. That's only the small aspect of things. The main aspect for architecture is what the municipality, as you suggested, is prepared to accept, is prepared to adopt, to adapt. You see, the municipality are involved in the stability of the structure, in the shape of the building, in the colors of the building, and in the method of construction. From what I know, let's take a little example of usage of precast element in the construction of houses, particularly where there is repetition, so that you can benefit from the economy of scale. An example is the buildings, the little villas that the Ministry of Social Development build every year and offer to the people. They build about 300-400 houses every year over the last 40 years. And not a single one is in precast. Actually, the only precast I've seen in the country are on industrial schemes, and the precast elements are coming from UAE, which is a shame. A shame for us, because we have the mountains, we have the cement, we have everything. Now, an example of municipalities' approval is a friend of mine has set up an industry to do precast housing 20 years ago. It took him about, I think, 12 years to get the municipality to approve under certain conditions the method to get them. Your question is very valid. Do we need their approval for restoring? I don't know. It's a very good question, and it's good to ask them. But to start building a full structure with earthen material and hope to get their approval, and I hope my grandsons, will be here in Oman to do a little house with earthen thing. We need the innovation spirit. We need a leader, a commitment in the municipality. We need innovation. We need research in connection or collaboration with geotech. You need a whole atmosphere of industrialization to jump to the new way of building with earthen. But for the time being, what is immediate, definitely repairing thousands of houses, of old houses that, I don't know if you visited Ibra. in Ibra there is Specha. There's practically a centre-ville, you know, complete centre-ville, and it is with villas around. The villas are disintegrating, but the centre-ville is still there. You have the place where the merchants used to sit down, the money exchanger, and it's a beauty. So we have probably to sit together, ensemble, Monsieur Rocher. We have to sit together and talk about where to start with this small thing. Thank you, Umayma. Where are you in Italy, Umayma? Where is she? She's gone.
Yes, I'm still in Italy. Until they open the airports in Oman, I'm still in Italy.
Apparently, you have a very fashionable corona there. We have a different one here.
Yes, ours has almost disappeared.
Take care.
Thank you.
Thank you very much. We have another question from Mr. Talal. Mr. Talal, please go ahead.
Yes, just Assalamu alaikum. Thank you for the great discussions. Just
Dr. Talal.
Dr. Talal, sorry.
No worries at all. It's just the name as the title. So, if you look to the average energy intensity consumption in Oman for the residential and commercial, usually we calculate it based on kilo BTU per feet square for 1 year. So the average here in Oman, we did a massive survey. It was part of Oman 2040. It was around 120,000 BTU for 1 feet square for 1 year. So the average in the world is usually around 40 to 50. And that was a different, we realized that how much energy intensity that we are consuming for the current energy building. We didn't put in that the source of the energy that came for the product material. If you look from macroeconomic point of view, we are utilizing gas to generate those products. We are utilizing gas to generate the energy consumption in Oman. And the price of the gas is $4.5 per 1,000 per 1,000 BTU. So the amount of saving can be huge if that just put as a number. And I'm sure this is the right time to propose such initiatives to the decision makers, where saving is a key driver for every single project, from government, from private, from other sources. So this is just a recommendation to put it with the current context of using earth material. The second point is regarding the product approval. I understand it's coming from هيئة المقاييس in وزارة التجارة, the standardization. The current move in the standardization, it is to utilize the global standards, like one of the use in the green building. I would really keen to see the Muscat municipality approve the green building code, which has been almost on their desk for more than 2 years. I would be keen to hear about it, and maybe Dr. Hanan can give us an advice. The third element, financing those projects which utilize the earth material. I want to ask questions for the expertise here. Can we utilize the carbon credit saving potential that countries around the world utilize it to finance such projects? Oman is advancing on the Sustainable Development Goals, and I'm sure that we have His Excellency Ambassador Musa Ta'i and others, where SDGs has been utilized as a key driver for many KPI. The goal number 7 or 6, which utilize affordable energy, that Oman advanced on it compared to the neighboring countries. So can we utilize the carbon credit systems where we can finance those projects? That's my question. Thank you very much.
I would like to comment on that after.
Sylvain or Wayne, would like any one of you would like to give a comment or to give feedback on Mr. Talal, please?
Can I give you my experience in that, Dr. Talal?
Yes, please, by all means.
Thank you. You can definitely benefit as a bonus from the system of credit, carbon credit. We, as I mentioned, we with German company. Actually, we have a small share. We have the largest reed beds, and we are getting bonuses from carbon emissions. Now, to get finance to do a project that reduces carbon, I don't think so. But if we do build with Earthen thing, we may apply to get bonus from carbon emissions. Thank you.
Thank you. Another question from Mr. Salim and Yumi. Mr. Salim?
Sorry, it was a disconnect when I start talking before. Just if I go back to what Simon mentioned, from my experience, normally we tried in Nizwa for what I mentioned about the mud house. There's no standard or regulation for maintenance or even doing rebuild all of the mud houses. So far, what they are issuing by regional municipality is just a maintenance permit.
Sorry, to just what?
Your voice is breaking again. I will stop your video and then you can carry on with the voice. Please try now.
Okay, yeah. Yes, I think, just going back to what Simon mentioned, about standard and regulation. So far with regional municipality, there's no standard. And normally they're issuing a maintenance, that's what we did for all mud houses in Nizwa, near the Nizwa fort. And they are issuing a maintenance permit. And then most of the people, they do the maintenance or rehabilitation in their own way, with coordination with Ministry of Heritage. But I think, if they set a good regulation and standards with coordination between all the concerned parties, that it will make things different, because now what we can see that people, most of the what they do in the house, they do it mixed using the modern material, and what they do, they're using the mud or that type of gas, they call it in Omani, just for plastering. But still, the condition of the material, it is not same what is being used, in the old time. I think that's a very important thing if we need, because we are very rich in this. We have many of villages in Oman, all around Oman. It is a big assets for us, for tourists in the future. And many of tourists, when they came to Nizwa, was done, they are appreciating, they like it very much. And that's what I think it is a good approach. It should be, as engineer, we should approach all the municipality and the concerned party. Thank you.
Well, thank you, Salim. That answers Umayma, and it sheds lots of light on what we wanted to know. Thank you very much.
May I say something to this? First of all, Simon, thank you very much for offering that we could start maybe on a small project, on a private project. I think this is always a good way to do it, because it's probably easier to start with. However, I think, and this is where we came from in UAE as well, and other neighboring countries, when you're talking, and this is exactly what has just been told, if you're working on a heritage project in general, you don't need the same kind of approval mechanisms from the municipalities, because it is a heritage project that needs to meet the standards, the international standards of conservation from UNESCO, etc. And usually the authorities, especially when the Ministry of Heritage is involved, they want to make sure that those are followed. This gives you a chance actually as well to start with initial projects where do some restoration.
Mr. Sylvain, your voice is echoing now.
Mine is fading?
Is echoing. There's an echo sound coming from your end.
I don't know what to do.
Yeah, now it's getting better. Just talk slowly. Yeah, try now. Yes.
Okay. So I think it is actually a good way to do a heritage building where do some conservation. And if you want to add a new element, normally you also have standards in order that you have to follow to not disturb the appearance of the heritage. And what we are always arguing, and this is going exactly along with UNESCO standards, is if you have an old building and you're conserving it and you put a new element to it because it needs some, let's say, some administration additional, then you can also follow those traditional building principles, and like this it's easier to get a first approval by the authorities and convince them then in the same time that this is the right way to do, and it could be a first step, you know.
No, Sylvain, I was not talking at all about national heritage. Forget about that. That's a totally different subject. I'm talking about a house owned by an Omani, owned by a private, like the example Salim has given, and who applies for restoration. But we restore it the proper way, not like in Nizwa. What they've restored is crumbling. We restore it in a modern way, in your way, designed with a nice interior, and turn it into a commercial bed and breakfast arrangement. You see, we have something similar built in Ziggy Bay. Something built, I have not been there, but I passed by the sea by there. They charge $1,500 per night. People want to live that experience. I was more thinking about a private project owned by a private man, not involved heritage, nor the United Nations. Just small, say two floors. There are many, millions actually, well, not millions. Let me be modest, thousands. We can identify. Many Omanis came to me and they said, look, I've got this old house. I want to turn into bed and breakfast. But that's not my job, it's yours. Maybe we should, we should think of starting something like that. Thank you.
Simon, we have our house in our land now in Matrah, inside Slovakia.
There you are. Sylvain, your first vote premier client, your first client.
It was demolished by the municipality because it was ignored. So the land is there. We can see what we can do.
Yeah, we should try once you're back from Italy and I'm back as well. I would be pleased to go over to Oman again when traveling is easier again to meet those people who are interested and have maybe a look at this and other projects. It's not that we were not interested in working in Oman, completely on the contrary. It was only that we've been so busy with other projects. But I think Oman is actually one of the most interesting countries about the potential of earthen construction, much more than other countries we've been already working in. And this is why it would be really a pleasure to do so. So I'm very happy. I hope that we can somehow share contacts after this Zoom meeting. And once traveling will be possible again in a normal way, I would then try to organize a little trip to Amman again, and then we can have a look at this.
This actually, I'll just add one point. There's I don't know if you all gentlemen are aware of a project in Rustaq to have a heritage hotel. Are you guys aware of it? Anybody? Okay. Anyway, there's a very nice project in Rustaq for a boutique hotel. And the idea is to make it so that it blends in with the community and employs the community, etc. I have the profile of the project. They're looking for investors. If anybody's interested, let me know. I will be happy to connect you to the project. He's an architect himself. So I'm sure I'd be happy to connect you to him. I'd invited him to this talk, but he didn't seem to join. His name is Salah Al-Mazrou'i, if you guys know him. Anyway, I'd be happy to connect you, either one of you or both of you or anybody that's interested in meeting with him and looking at that project and seeing if it's possible to incorporate any of your technologies.
Right. Thank you, Maima. I would like to introduce Aleksandr Muller. He's an architect and a design manager, and he's working at the moment in Tasnim. So he can give us his experience and what he thinks about the earthen material. Go ahead, Alex.
Thank you very much. First, I want to say shukran to Khalil and Mohammed to follow our idea and to give us the opportunity to have this majlis on this topic. Secondly, I want to thank, of course, Sylvain and Wayne for their very enlightening lectures. And thirdly, I thank all the attendees for this patience and the passion about earthen construction. I'm really pleased because I also believe that Oman is so rich in heritage and earthen construction already. So wherever you go, you find all these buildings. And for me as an architect, it's actually breaking my heart to see them vanishing with every rain a bit more and more. If I could, I would even try to preserve the amount of clay washed away, and sometimes you just find a mound left. I would, apart from the technical aspects, what Sylvain and Wayne were talking about, I would rather go more for the comfort, because I feel this earth material, like Wayne was saying, has everything in it. You don't need to add anything else. So even the sandwich solution is not needed, because if you ram it or if you do it as a panel prefabricated, it's already there, everything what you need. You can even have the surface finished, so there is no need for adding a plaster, because the earth can be the material itself for outside finishing and inside finishing. And I would also emphasize on using earth material for plastering instead of all these cementitious material which are widely used in all the villas. You can plaster your block work if you have done them in cement. You can plaster it with earth material, because the effective layer of giving a nice, comfortable atmosphere to the room is just like 3 centimeters. So by adding a layer of earthen plaster inside, we would really, really improve very much the feeling of everyone inside the rooms. And probably also we would save a lot of air conditioning, because this is like a second skin. It acts like a balancing, natural balancing of the humidity in the room. And probably also if you take it a step further and you replace the concrete blocks as infill for your walls, we are not talking about changing the column and beam structure in concrete much. Like Wayne was showing the example, just do an infill with these earthen blocks. You will feel a huge difference that the heat, which is transmitted usually by concrete from outside to inside with a delay of 6 hours. So you go to bed in your bedroom and you still feel the walls somehow heating you, and you get maybe a sunburn by it. But with earth material, it's not there, because the earth will just distribute the heat evenly over the entire wall, and the effect is not the same. I would like to show, would also go back a bit more to the emotional part of it. We have so many buildings, and it's really like a matter of restoring them and translating the old construction method, whether it's with normal earthen material or sarouche, which is a burned material. And this burned material was used, like Sylvain was saying, more on the coastal areas, because there you have a higher humidity from outside, and the salt in the air is a threat to these old buildings, like you can see sometimes in Matra. So Sarouche makes a sense on these coastal area. Wherever more inside the country you don't need anything else. You just need earthen material and build your houses out of it. Use other natural materials to maybe the frame. Because why is the combination of timber and mud in Europe so widely used? Because the clay actually preserves the timber. So in case of a rain, the clay is taking the water away from the wood and actually preserves the wood. So this combination of wood and clay for the Northern Hemisphere is ideal. And I'm sure the same principle applies to the construction method in the past in Oman. And people survived thousands of years in these old houses without air conditioning even. Now in our new days, we are just using whatever's available and going away from the old traditional way, and it's actually sad. So I would use this, what I heard mainly in Oman recently, Renaissance, starting with His Majesty Sultan Qaboos, may he rest in peace, and with the advantage of the new Sultan being the former Minister of Heritage and Culture. I'm sure he is aware of the big heritage Oman has and what creates the identity of Oman as well. Tourists from all over the world coming for the combination of landscape and all these old places like Birkat al-Maus, Mana was mentioned, Niswa, Castle Jibrin, but we don't need to go so far away. If I see, like Rocher was referring to the pictures I shared with him on Al-Khud, we have a treasure, we have a gem in the old village of Al-Khud. This Beit Al-Ud is one of the most beautiful buildings in close vicinity to Muscat. But I will raise another issue, what I see sometimes with these buildings. There is a family who owns this. And let's say the building was constructed by the grandfather. But now there are so many children and grandchildren, so the family is no longer clear who is the actual owner of the house. And maybe we need to talk to these owners of houses as well to get an agreement with them that this is not a money-making investment on their houses, it's just to preserve the valuable buildings they have, and not, we can turn it into a business, yes, it may work as well, very well for family members, but we cannot sometimes please all 50 inherits of this, let's say like the Beit Al-Ud or something like this. When I go even further in Wadi Al-Khud, there are these beautiful al-Falaj structures. There are bridges built in this. This is all part of the heritage and needs a very, very quick decision of really preserving this, because I can see it disappearing and vanishing more and more the longer we wait. And that's why I also encourage this earthen building initiative started by Wayne, because it is the combination of what we have, what we can do, and what the future can be in terms of design, preservation, design of old stuff and new stuff, and then also how to industrialize the material. Because at the moment I can see also that we don't have ready-made plaster, like what Wayne was saying in Germany. We have this company called Claytech. They have bags of plaster you can buy, and you can mix it in your machinery and you just throw it on the wall and you do it. But here everything is still like a handmade process, because this infrastructure and this supply is not there yet for the building material, which is also certified and standardized and all this. So we need this to start with. And I would really encourage everyone to be part of it. And hopefully the Renaissance, which was a change in philosophy, art, literature, and architecture in Europe before, can or is necessary for this material in Oman.
Yeah, Alex, thank you very much. Mr. Caesar, did you have a question? Haji Adam? Haji Adam, do you have a comment?
Nope. Wait, can you hear me?
Yes.
Hello, can you hear me?
Yes. Go ahead.
Okay. Thank you very much. Very enlightening presentation. From my experience, wherever I go around, I see making mud bricks or earth bricks is much simpler. You don't need high tech, or you don't need huge investments. For example, in India, in Pakistan, in Bangladesh, people are trained to make these kind of bricks, and are available to people to buy them and build them. So I don't see a big issue, to be honest, with this one. This is the first thing. The other question I have, you look at the construction of old houses in Matra, because the houses are built of a combination of rocks cut from the mountains, local mountains, and mud. So can these two materials, can they be used in an economical way?
Yes.
Thank you.
Yes, thank you for your comment. I agree. I think that earth bricks have been made very, very simply. They're probably the easiest thing to make, very, very low skill, and not any technology involved. However, the reason why we propose this in a high-tech way is because we are trying to create something else. We are trying to create actually an industry which is much more efficient, because when you do things handmade like that, you run into the problems of logistics, and contemporary construction is based on very tight time frames. It's based on consistency of the product and standardization. And the only way to achieve those things is really by going into the industrial processes. Also, what we saw is that we saw the potential to allow Omanis to become interested in participating in construction again. This will, in my opinion, and based on what I've heard from other people, this will never happen when we have a low-tech process such as making mud bricks. No Omani will ever involve themselves in doing that. And to be honest, I also would struggle to find myself interested in something like that. However, I was very interested to participate with a company that was manufacturing these earth blocks at an industrial scale, using very, very advanced machinery to do it in a very efficient way. This, I feel, has more potential to involve native Omanis back into the system of construction than handmade earth blocks. So this was really the driving factor behind it. Your second question about the combination of earth and mud, yes, in fact, most of Oman is built with this combination of stones and earth blocks. And one thing that the stone provides us as the most obvious thing is, as Mr. Sylvain mentioned in his presentation, we need a foundation which is resistant to water. And so the stone foundation, this is why when you go even into Tahliya, you always see the mud houses resting on a pedestal, really, of stone. This is a perfect way of using natural materials and then combining it with the mud products.
Thank you.
Thank you very much, Wayne. I would like Dr. Mohammed Abdel Hadi. You had a comment? Dr. Mohammed? No. Okay. I would like to end this majlis with just a few comments. I know Wayne, I've met Wayne before, and I know what he has done with the students, and I really want to talk about how the students can really affect in the future. Because when you have a young generation coming up with that knowledge, it can really affect what will really get built in the country. Because if you're going to have architects that are going to build out of concrete, then that's what will get built. But if you have architects that will want to build with earthen materials and be very sustainable, then that's what will really change in the future. Of course, you cannot change very quickly. Of course, with architects that studied 30 years ago, even 10 years ago, they probably had no idea that they could build out of mud. But even in the UK where I study architecture, it's only a very small percentage of the course that is about earthen materials. I was very surprised that when I came to Oman and I met Wayne, actually they have full projects on earthen materials. So I really hope the future is bright for Oman, and I would really be happy if I saw buildings made out of it. And myself and a couple of my good friends, we're trying to build that ourselves. So hopefully once that's ready, we will share. Thank you very much, everyone, and thank you, Wayne and Sylvain, for the great presentation. Thank you very much.
Thank you very much.
A new Shahbandar is born today. Thank you, Muhammad.
Thank you very much.
Shukran.
Thank you, everybody. Thank you.
Thank you. Bye-bye.
Thank you, everybody. Thank you. My pleasure.
شكرا. مع السلامة.
مع السلامة.
Thank you very much. Thank you very much.